We're going to tackle one of your core required practicals for AQA GCSE Physics, figuring out density.
Let's dive into the core idea. What actually is density? What are we even trying to measure here?
Density is all about how much stuff, or mass, is packed into a certain amount of space, or volume. Think about it. A kilogram of feathers takes up way more space than a kilogram of lead, right? That's because the lead is much, much denser. It's the same amount of stuff crammed into a tiny space.
The density formula triangle. So if you want to find density, you cover up rho, and what are you left with? Mass over volume. So the formula is density equals mass divided by volume.
Right, so the formula tells us we need to find two things to calculate density, mass and volume. Now, measuring mass is usually pretty straightforward. You just stick it on a balance. But measuring the volume, that's where things get interesting because it completely depends on what you're measuring. You have to ask yourself, is my object a regular solid, like a perfect cube, or is it an irregular solid, like, I don't know, a lump of rock or a door key? Because how you find the volume is totally different for each one. A regular solid. First, you find its mass on a balance. Then, you just need a ruler. Measure the length, the width, and the height. Chuck those numbers into the right formula, like length times width times height for a cuboid, and you've got your volume.
What do you do with something like a rock? You can't exactly measure its length with the ruler, can you?
And that solution is called the displacement method. First, you measure the mass, just like before. Then you grab a special piece of kit called a Eureka can and fill it with water right up to the little spout. You pop a measuring cylinder under that spout. Now, you very carefully lower your rock into the water. The rock pushes or displaces some water out of the spout and into your measuring cylinder. The volume of the water you've collected is exactly equal to the volume of your rock. Okay, what about liquids? You put an empty measuring cylinder on your balance, and then, this is important, you press the 0 or tare button. Then you pour your liquid in. The reading on the balance now gives you the mass of just the liquid, and you can read the volume straight off the side of the cylinder.
So you've done all your measuring. You've got your mass, you've got your volume. Well, now we need to process those numbers.
The absolute best way to keep everything straight is to draw up a nice, clear table. Get your headings right, mass, volume, and a final column for the density you're about to calculate. It just makes everything so much easier to see.
The calculation itself. We just need to plug our numbers into the formula we talked about. Density equals mass divided by volume. Don't forget your units. It's grams per cubic centimeter. To really hit those top marks, you've got to show the examiner that you've thought about how accurate your results are and what you did to avoid making errors. Did you make sure the balance was at 0 before you started? When you read the volume, was your eye level with the water? When you put the rock in the can, did you do it gently so water didn't splash everywhere? And did you only measure once?
Always take repeat readings. Do it 2 or 3 times. This lets you calculate a mean average, which is much more reliable. Plus, if you get one really weird result, an anomaly, you'll spot it straight away and can ignore it.
A 6-mark question pops up asking you to describe, step by step, how to find the density of an irregular object. What do you absolutely have to include to get full marks? Here's your roadmap to 6 marks. Follow these steps. 1. Start by stating the equation. Density equals mass over volume. 2. Explain how you measure the mass, mentioning the specific equipment, a balance. 3. Describe in detail how you measure the volume, in this case, using the displacement method with the Eureka can and measuring cylinder. 4. State that you then use these two values to calculate density. And 5. The cherry on top, add a point about accuracy. Mention avoiding parallax error or repeating your readings and taking a mean. If you hit those 5 points, you are well on your way to getting every single mark. And there you have it. That's your complete breakdown of the density practical. So we'll leave you with one final question to think about. You've done the experiment. You've calculated a value. But how do you know if it's right? How could you check how accurate your number is? If you can answer that, you're really starting to think like a scientist.